Okay. So, good morning and good evening to everyone, depending on where you are from. So, my name is Dolcy Dhar, and I'm currently working as a junior data scientist at CellStrat AI Labs. And my main area of expertise is AI in healthcare. So, today I'll be taking a basic topic of one of the prompt engineering techniques, and let's dive right into it. So we know that prompt engineering is the new hype because of the ease it has made for us to talk to these large language models these days, and it's nothing but a way of writing English, ordering your thought in such a way that you get the large language model to do what. I think someone is on unmute. Can you please mute yourself? Okay, thank you. So, uh, before we, get into the different types and, why we chose graph prompting and what are its importance and everything, I just want for everyone over here today to have a look at the anatomy of a prompt. So this is an example of one shot prompt. So what is known as one shot prompt? One shot means one example. So short means example. So here you can see that the prompt is divided into sections where there is an instruction which says that you will be writing a product launch email for a new headphone. So that's the instruction. Now, what would be the data on which the LLM will write the information, like write the email? That is the second line. That is the input data. The product A is AI powered and priced at rupees 21,000 and everything. So that is the main data that the LLM has to use. What is the context in which or the environment in which the LLM has to write? That has been specified with the tone is friendly and exciting. All right. And again, we have to specify all the
No, Dolcy,
instructions.
have you moved your slide or you are still on title slide?
I have moved my slide.
We are
Not
still seeing the title slide.
okay,
And now
okay.
we see the second slide. Okay.
Okay. All right. So let me just quickly recap this. So, well, I just wanted everyone to go understand what a prompt looks like. So, this is the prompt anatomy. So, the prompt anatomy will have, different things. One would be the instruction, which would specify what the LLM has to do. So, like how I mentioned, that prompt engineering has kind of made it easier for us to talk to these large language models, but because it's a computational model, it's a discrete model based on certain mathematical, calculations and formulas. You have to be very clear and very specific in, laying out what you want the LLM to do. So this is how a prompt
Maybe
exactly.
you want to put it in presentation mode, so that will be full screen.
Sir, I have been putting it in the presentation mode.
No, it is showing all the controls at the top,
Okay, let
PowerPoint
me
control.
reshare my screen. I think this
You
would.
share all when you share all full.
Ha, yeah. Now is it better?
No, it is still in editing mode. Yeah,
Now?
now it's presentation. That's right. Thank you.
Okay, okay, great. All right. So sorry for that. Anyway, let's come back to it. So instruction, like you can see on the right side, we have all the components of a prompt. So you see the instruction. You will specify what the LLM has to do. You will give the data, the input data that the LLM will use to carry out the instruction. You will set a context. So here context means an environment or a setting. So right now, suppose you guys have joined this webinar. So the context is the webinar on AI. The instruction would be to conduct a webinar in graph prompting, and the input data would be all these PPT and information. So this is how you explain what a prompt does. It kinds of lays out a blueprint for the LLM to follow or carry out. The target format tells the LLM in what the output, like what should be the output format. And an example, like I mentioned, one shot, few shot, these are like example based, techniques where you can, like, guide the LLM, give an example to the LLM or multiple examples to the LLM so that the LLM knows what it has to do. And it can always come back and, verify whether it has done the right job or not. So this is again a little bit in depth of the prompt design, and is taking an example again. So let's not spend time over here. Now, the reason why I'm taking you through the prompt anatomy and now this topic is to bring everyone on board. Before we dive deep into graph prompting, I want you to understand that there are these few basic things that you have to know. So prompt anatomy was one, and prompt chaining is another thing. So how do you understand what prompt chaining means? So basically, you have multiple phases, and you chain them kind of like in a row. So if you see the slide over here, you will see that this is like a pipeline where first you extract entities. So this is like an example pipeline of how you can leverage different types of prompt chaining, like a type of prompt chaining where the first prompt was specifically designed for entity extraction. There, after the LLM responds, so you can see that the LLM has extracted entities just below it. You can see that we had given a sentence called the new iPhone model is set to be released next month. It has been highly anticipated by Apple fans, like how it is. So we've asked the LLM to extract entities. It has successfully done so. It has given us iPhone product. Apple is the organization. Now, we want the LLM to do multiple things, not just extract entities. We want the LLM to summarize as well. So we sent a sentence, we extracted entities, now we want to summarize that entities. So that's what the LLM does. The next prompt would be, please summarize the output of the previous step, something like that. You will have to specify it in English and clear outcome language, and that's how the LLM will follow. And the third step was sentiment analysis. So here in the second step, the LLM was asked to summarize, and again on its own summary, the LLM was asked to provide a sentiment. All right. And in all of these cases, there are three different tasks, but the steps have been carried out. So this is like a new technology, you can say, or a new method, you can say, that can help us leverage LLMs into multiple things. So here I'm showing you three steps. What if you can go further and, maybe do a classification step at the end? Suppose you can do a user reception test where you can ask the LLM to take the context as the previous answers and decide whether iPhone has been important, or whether iPhone has a very good following in the user segment or not. So you can add as many steps to this chain as your storage and time permits. You can do that, and you will be able to modify LLM's behavior and make a good use case or a good pipeline out of it. So now, importance of AI prompting. Why do we need AI prompting? Again, we were like how I told you, it has made our lives easier. These large language models are, very difficult to code, and it takes a lot of years and a lot of training to, get them to do what they're doing right now. But prompt engineering kind of, uh, bridges the gap between the efficiency of that large language model and kind of like a trade-off with the storage and the compute time. So instead of retraining the entire model like how we were doing in even in traditional ML, we would retrain the model. Here we don't have to, so we are saving so much time. I just have to write in proper sentences and the LLM would understand. So we have come a long way when we see computational large language models and traditional ML. They're more user friendly because it's easier. People know English. It's easier to write clear instructions in English than hard coding or fine tuning a model. Smart decisions, because these AI are like you better at faster decision making. So even chat GPT's response time is approximately 15 to 20 seconds. So that's basically seamless, right? Because initially when we were using computers for heavy duty data, like even medical data. So I come from a healthcare background, and medical data is really huge and like storage intensive, and we need faster decision making on that. Prompting kind of makes it easier for us. So I can like use same, I can design many prompt templates for different use cases, and I can use the same LLM and streamline tasks using different prompt templates. So one prompt template for like extracting entities, one for summarizing, one for sentiment analysis. I can just go through them, right? I can just write the code, like write the prompt once and use them multiple times. So smart decisions, that's how it increases your efficiency, it boosts your productivity. So AI prompting has become a very important part, for generative AI these days, and it's rightly so. Just to take you through a few types of prompting that we do. So there are, if you see on the right side, upper left, upper right quadrant, these are all example based prompting. So zero shot is no example. So if you have very simple use cases like a Q&A, or just a small summary, you don't have to probably give examples for that. One shot is what we saw in the beginning of the webinar. The one shot is like one example that we kind of like specify. So usually what happens is when you have to specify the output of the LLM, the formatting of the LLM output, you use these examples to kind of like guide the LLM to give us the answer in the way we are wanting, so that we can, we don't have to format the data received again and pre-process it to for the user to view it. So that's why these prompting techniques come into place. Now, on your left hand side and the left quadrant, upper quadrant, these are all your reasoning based techniques. So, what do you know? What is known as reasoning based techniques? So reasoning based techniques is where you ask the LLM to kind of like reason to do something. So when you write an entire project, let's say a generative AI lifecycle, or even traditional AI project, and suppose, let's say for the sake of this webinar, we can say that you are able to use prompt engineering there. So, what you would do is that you would employ the prompt chaining technique, where you would specify the logic of how the LLM will progress from the first step to the second step to the third step. So, like how, let me quickly go back to this page and show you. So, here I have specified the logic in which the LLM will, carry out tasks. So, first, the LLM is supposed to extract entities in a specific format. Then it is supposed to summarize those entities and those relationships, and then the summary should have a sentiment attached to it. So I've specified a chain of thought here. So thought, nothing but in this context, flow of logic, or flow of sorry, flow of logic is the thought over here. And chaining is what we are doing, is basically putting it one after the other. So that's how reasoning based reasoning based prompting is what we are able to do. So chain of thoughts is what we saw as an example. Tree of thoughts is somewhat similar to kind of like decision trees, but where you will be dividing at every step. You will be deciding whether the LLM will go left side of the tree or the right side of the tree, and that's how it will progress. An algorithm of thoughts, like as you can read from the word itself, would be like you specify a particular flow in a more complicated way. So chain of thought would be very simple, tasks being chained. Algorithm of thoughts would be more complex, where you at every step the LLM would be, making multiple decisions, or deciding a few things, and only then moving on to the next step. And basis on the first step decisions, the second step decisions would be modified. I hope this is clear until now and it's not an overload of information for you guys. So,
I mean, this is very fascinating. I feel as a community, we haven't done a lot of prompt,
yeah,
engineering or prompt techniques yet. So we have a whole, ground to cover on, because we have just heard some of smattering of these, but not really
mm,
gone deep into most of these. Maybe one shot, few shot we have done, but
yeah,
rest of them are still sort of a mystery. So a lot of research we'll have to do in this. So this is good stuff. Yes. Audience, feel free to ask questions. This is very fascinating content, as you can see.
also, the thing is, so right now when I was telling you guys about, this is the example based, prompting, these are reasoning based promptings, so the left hand side, and this is information based prompting. So there are so many types of ways we can actually leverage or incorporate human logic into our generative AI projects, that we don't even have to we can think about fine tuning and designing a model from scratch a little later if we explore these techniques faster first. So here I want to just clarify a few things. Now you must be seeing graph of thoughts, knowledge graph prompting, meta prompting, information retrieval. So I want to explain to you a little bit. So when we are talking about prompting, we have to there's a very big assumption that you have to meet, that is that you are not changing the LLM weights at all in any way whatsoever. You are using the LLM as it is, and then you are applying your way of, format of writing things, or your logic, or your workflow on top of that, and then getting an answer. So please, nowhere here we'll be fine tuning or, changing the model weights. We won't be changing, we'll be using the end result. And just a clarification here, these are all high level, higher logic level reasoning and type of prompting. So in knowledge graph prompting, you kind of like do two ways. One is either you leverage an existing knowledge graph of for prompting and for answering questions. So graph is a type of data structure that can model abstract relationships and more realistic entity relationship capturing is done by graphs. So you can either we'll dive deep into knowledge graph prompting and all types of graph promptings basically as we move further. So let me just take a quick look if anyone has any questions on the chat.
Yeah, sure. I have one. It's like, what metric do we use to know which prompting is good for our model?
What metric are
Yeah,
you saying?
what's the easier
So,
metric? Because there are quite a lot I see. So, what's the easiest way to figure it out?
okay, so I think there's a lot of rather than just moving into matrices, I think it a lot more depends on what kind of use case you have. Okay, because I would be honest with you, we kind of like jump into evaluation right away, but I want to understand that if there is a need of prompting at all. See, if you're using the LLM models directly, and you have to understand, whenever you're sitting for this generative AI project, or whenever you're sitting with a computer science project, you have to understand what can the computers do, because it's based on discrete mathematics. There are only finite number of operations the computer will be able to do. What are those operations? You don't have to go into the mathematics of it. So see, the LLM can do text generation, it can do text summarization, it can extract entities for you, it can do sentiment analysis. So these are all the options that the LLM inherently can do. Now, what is your use case? Do you want a combination of the inherent qualities of the LLM, or do you want to apply your own logic? So if you have your own logic, so suppose right now I have a product called a search engine. We are building, CellStrat is building a product called CellBot, which we can see at the end of the session. So there we are applying, we want something called the LLM to kind of assess whether the LLM should do this step or not, whether it should take this decision or not. So we have multiple decisions the LLM makes within the workflow there. So in those cases, reasoning based techniques, so chain of thoughts actually helped us a lot. We didn't have to go to tree of thoughts at all. And there's we think we might need graph of thoughts, but so graph of thoughts honestly is a little bit more extensive. So whenever you move from one shot to zero few shot to these higher level prompting techniques, your cost and storage extent, like compute also goes up. So again, your use case will decide which one to go with. But you can have a fair idea whether your examples would be enough. So if you have inherent LLM qualities, like what the LLMs in with text can do, you can go with these short examples and then use these scores, the evaluation scores, to try. So in any case, you will have to use multiple prompting techniques and apply those evaluation scores. So I think there's a blue score, and there's a rouge score, if I'm not wrong. So these scores you can apply to all of your prompting techniques responses and then decide which one would be best. I hope I did not confuse you. I'm not sure who asked the question though. So,
Yeah, I got it. So I'm
okay.
looking it up. There's blue score and rogue score.
Yeah, so these are like evaluation matrices. There are many evaluation matrices as we, go forward. So it's not exactly about just evaluating prompting. Also, it's also about evaluating the LLM response, right? How does the LLM respond? So it will change. It becomes subjective, because it's in English. You can write better English, maybe the LLM would understand better English than what I'm writing right now. So yeah, it's all about hit and trial. So,
No, but
but
I think blue and rouge is very much like a fundamental
hmm,
metric for
right,
measuring the quality of the responses that is coming from these LLMs. Especially in the rouge, there are again rouge one, rouge two, rouge
routes
three,
three.
like that. So a lot of platforms they are giving some inbuilt
Hmm.
measuring techniques, which helps to some extent. But as you said rightly, that some of the things are like completely dependent on the use case and how you are basically measuring it. For example, summarization and sentiment both can have a completely different measuring criteria. In that case, let's say you chose Rouge score or Blue score based on what type of task that you are performing.
Yeah. So,
I can see.
there are so many, when we talk about computational techniques, there are so many costs that we incur, right? We always have people talking about how much storage will it take, or how much compute time will it take, how much do we have to pay for cloud services, and all of those things. So you have to keep in mind everything. So as as a project manager, or as a project doer, you can say developer, you can say, you have to keep in mind. So this is like a first step thing. In order to save money, and in order to not move into fine tuning and recreating a model from scratch, prompting, if you explore prompting extensively, I'm sure 90% of the use cases would see an increase in accuracy, because LLMs are that capable now. If it was like 3 years ago, maybe with bot models and all those things, maybe prompt engineering wouldn't have made a difference much then, and fine tuning and retraining the entire model made sense then. But with chat GPT and Gemini models and Llama 3 and all those models coming in, which have very long dependency understanding and long context windows, I think prompting kind of uh, is more than enough for many of our use cases, I would say. So, just again, a small recap into a few examples. So, you can see I'm using the prompt template from Line.
Just a second.
Yeah.
You gave 4 types in the previous slide: example based, reasoning based, and information based. What was the fourth one for graph of thoughts and graph prompting? What
So,
is
yeah, these are all reasoning based. So the left side is
oh,
entirely reasoning based. This is information based. I'm so sorry. Actually, yeah, this is just to specify everything on a scale, and these are example based.
I see. Okay, okay.
But
So
so
graph is
yeah,
it's
tell me.
reasoning based as well.
Yeah, it's a reasoning based, but it's a little so you have to understand these are all very straightforward. Tree of thoughts, chain of thoughts are
Hmm.
very
Yeah.
straightforward, but graph of thoughts and graph prompting are like actually a little different, and it's a little higher level of reasoning, and that's why I've mentioned it a little separate.
Okay,
ठीक
I
है?
see.
And I have changed. So even though knowledge graph prompting is a type of graph prompting, I've mentioned it separate because it utilizes external data sources, which inherently, prompting doesn't exactly does. But you can specify, or you can specify the context and the input data, right, in the prompt. So here you specify external data sources in the form of knowledge graphs to kind of leverage the LLM response. ठीक है?
Okay, sure. Thank you.
Just if you could, just one question I have on the
Yeah,
previous.
yeah, go ahead, go ahead.
So first question is that you presented this in two-dimensional setup. So do these dimensions mean anything in the previous one?
Oh,
Uh,
no, no, no. That's just a way of
okay.
specifying. No dimensions, nothing. That was not a graph of any sort.
Okay.
It's just what I've make it look appealing for everyone and kind of like a crude distinction so that people remember it more. You'll remember example based, reasoning based techniques faster than me listing out, in a 1 to 10, first is few short, then this, and then that.
Understand. Okay,
Yeah.
then the second question is, I think, kind of related to some questions on the chat as well as the previous question on
Okay, let
evaluation.
me check the chart as well.
Yeah. So the question is that I know that all of these techniques are quite, they are quite evolving pretty fast, and a lot of papers being written and everything, and so on. But basis your experience, is there any kind of, hey, these are the kind of use cases which are better kind of solved pretty quickly with this kind of potential prompting and so on? So is there any experience you want to share?
Uh, okay. Well, I think prompt engineering. So now I haven't had the need to, kind of push in my company to, fine tune a model. Coming from a healthcare background, medical data is very intensive and very heavy, computationally heavy. And it takes a lot of time to kind of do storage on that and, make inferences out of that. But until now I feel that prompting has taken care of most of my use cases. And again, I would tell you, if you're capturing the LLM's capability. So let me quickly take you guys through what LLMs can do. Okay? So uh, what are large language model uh, functions, or if it could give me, so it can recognize, summarize, translate, predict, and generate the next token. So you have to understand that if you're using a text model, say Gemini or GPT, when you're using it for text cases, for text data, suppose you're using PDFs or you are using Excel files, something like that. I think prompt engineering, if you dive deep into it, and I can be wrong here, but prompt engineering would probably solve most of your problems there. You wouldn't have to fine tune it. But let's say if you go on to a little higher level data. So suppose because me being from medical background, I have different kinds of vital monitors, sensors. So maybe their prompt engineering won't work for me to correctly identify the signals from the sensor, and for the LLM to interpret, I'll have to modify the data in such a way that the LLM understands. So if it is text to text, the LLMs can easily pick up. If it is images to text, again LLMs can pick up because now we have multimodal LLMs. But when we move into, like, say, another dimension, or let's say Now we have audios as well, we have videos as well, but medical data, we don't have LLMs which are currently trained on MRI. They're coming up. They're trained on medical data, but they're not trained on MRI images per se. So in those cases, if I come make a use case out of MRI data, I would need to start a model from scratch. But for text cases like summarizing, translating, or doing RAG, so if you've heard of RAG, which is retrieval augmented generation, so for that also prompting has kind of solved my problems. And chain of thoughts only, I didn't need to go to a higher level of prompting as well. Few short example based promptings or chain of thought prompting has mostly solved most of our problems until now. Oh, and I'm hoping it solves further also. But yeah, if you delve into higher dimensional data, maybe let's say data frames, or more heavy duty datas or higher dimensional Excel files or something like that, then you would probably need to think a little beyond prompt engineering. So Indrajit, you can correct me if I'm right, if I'm wrong, if anyone has. Okay. So,
I have a question, if I could.
yes, sure, Samrat. Tell me.
So, I've been using GPT and I've been using Gemini for like large scale
Hmm.
sentiment analysis with certain data sets. And what I've been noticing is that GPT especially has been creating false positives that later in my post processing steps, it's able to detect that this is a false positive and get
Hmm.
mistaken coming up with it. So is there any standard in how to like mitigate or reduce this error percentage that, or at least the false positive error percentages that come up with this?
So I think what happens is you have to give the LLM maybe, so like how you told me yourself that the LLM is able to identify itself in the post processing step. So maybe you can try chain of thought, where you kind of like attach a guardrail sort of a thing, where the LLM responds, and then within the pipeline you ask the LLM to re-evaluate its answer, and if it is not satisfied, it regenerates the answer. So chain of thought would probably solve this. So a rule of thumb would be that if your LLM has understood your task and it is performing, say, like 70% of the time fairly well, then in that case, from example based prompting, you should move to reasoning based prompting. So this is how you move forward, because first you try with the example based prompting, and if the LLM responds well and good. If it doesn't, then you move on to chain of thoughts, and if it doesn't work with there, then you move on to tree of thoughts, because you will be increasing your compute time and your storage time drastically from moving from example based prompting to reasoning based prompting techniques. But you will see a drastic improvement in your LLM responses and accuracies. So from example based techniques, if I show you guys from example based techniques, you can, yeah, so you can see that here the online system over here on COT has increased by almost 7%, you can see. But example based techniques were not that bad. So it is interesting to note that from example based techniques to reasoning, you see a very increase in accuracy. But from within reasoning, if you move from say chain of thoughts to tree of thoughts, you won't see that much difference, hardly 3% or 5% difference. So again, coming back to your question, in your use case specifically, I think you should go with chain of thought, and that would drastically improve your responses, where, because you have to understand that LLMs have been designed to act like humans, right? To think, they can't think, of course, but to behave like humans. So we have to leverage those human capabilities instead of us hard coding everything and specifying everything. Let's give some control to the LLM itself. So that's what these prompting techniques, these reasoning based prompting techniques help us do. We ask the LLM itself to decide whether the answer it has given is correct or not. If it feels that no, it is wrong, And most of the times these GPT models, they understand that the answer is wrong and they recorrect themselves. So maybe one extra step of evaluation within the chain would drastically improve your answers and cut down on the post processing steps that you take.
Yeah, I think that sounds like it would be effective. That's what I was considering as well. I'll add a post-processing step now.
Yeah.
Thank you.
No worries, no worries. Okay, just there's one more question on the chat. Let me just figure that out. So, Shrishti says prompting is used while training or when using LLMs to get answer. So, Shrishti, prompting is used everywhere. So, prompting is used even during, pre-training the model, and when the foundational LLM is being made, prompting is done to kind of like guide the training of the model. And even during the second step where there's something called supervised learning step or instructional fine tuning step. So the second step of training a large language model kind of also employs prompting, where you guide the LLM to generate answers, and you mark those answers, and you kind of like fine tune the LLM on specific tasks, so say Q&A, summarization tasks, entity tasks. So different types of prompts would be used there. And depending on the level of the model and the context window and the features it can take, it will be decided whether it is going to be example based prompting or reason based prompting, because maybe smaller models would need reason based prompting and larger models would be fine with giving them an example. Like how older kids are very much capable of understanding the task better, and younger kids you have to specify the entire workflow. So something like that. Please mention one use case for graph prompting. So Milan, I think you can use graph prompting in let's say a medical diagnosis pipeline, where you are setting up an LLM pipeline where the LLM decides based on the information received from the patient whether the patient has a particular disease A or not. I hope that answers your question. All these prompting don't need GPU usage, right? Yeah, we can do it. We can do it locally. Because you are not changing the model weights, and most of the cases, if you're calling these large language models, you make an API call. So yeah, you can do prompting locally. No need for CPU. So no need for GPU usage and all that. Okay, I guess. How many types of prompting are there other than graph prompting? So yeah, the ones that I showed you, you know, just a second. These are the type of promptings that we do these days. Anyway, we'll be sharing the PPT with you, so you guys can check it out there. So just to take you coming back to the presentation and taking you through a quick example. So this is a zero shot prompt because there's no example over here. And this is a few shot prompt template because there are two examples. You can see here the word. There are two examples over here where you're giving the LLM a template of output that you want. So diving deeper into the workflow, like how I was telling you about chain of thoughts. So the basic input output is like you ask the LLM a question, it responds. So this would be a basic Q&A. So the reason why I've designed this slide is to show you the flow of information and to also show you that there is no overlap of information between steps over here. As you can see, if you within the tree of thoughts, if the model decides to go left, it will not go right again. It will start through this path and it will reach the leaf node through this path only. So that is how the LLM's reasoning is guided to come to arrive to, let's say, a common decision or to a correct decision. So this is how the flow of thought, thought is. So you can see the arrows over here. Now, moving on to, graph prompting. So I want to mention a thing over here. Graph prompting is, in broad sense, is leveraging graphs in the form of prompt to drive LLM logic. Is, in simple terms, you can say. And graph of thoughts is a type of graph prompting. Okay, so there are multiple types of graph prompting. So graph prompting is nothing but leveraging graph data structure in any form whatsoever, and deciding, and guiding the LLM for the answer. So as you can see, we see that the flow of information is a little erratic. You can the model can start here, and it can come here, and it can redo the step over here, or it can, jump onto the right side. So basically, you know how graphs are, that's non-linear path. It basically models relationships between different entities, and those relationships can have, overlapping sections, or those relationships could culminate into a common section. So like how you can see that three reasoning steps come down to one step. So graph kind of, helps you model human thought or human thinking effectively. Anyone has any questions over here before I move forward?
I have one question here.
Sure.
Like, let's say you were mentioning about that medical data example. Like, let's say if I have some kind of prescriptions from doctors, and then I will store it. Then my goal will be based on the data stored. If I have some kind of disease related information, so then that should tell like what type of disease, or what are the prescribed medicines for that, right?
Yeah.
So that if I have this kind of problem, so now are you saying the first step is to figure out the thoughts, whether it will be falling into graph of thoughts or one shot, few shot, or reasoning?
So see, domain expertise kind of like, comes into picture. So now you have specified that you have medical prescriptions with you as data, and some data on diseases, right? So
Right.
you want to ask the LLM that based on the prescription of the medicines, can you tell us what the disease is, right?
Yeah. Yes. Yes.
So in this case, now this is use case specific also. My domain expertise says that in the first step, you will ask the LLM to extract the information from the prescription. For that, you will use prescription would be in the form of an image. So you'll have some form of CV or OCR thing going on there, where you'll be recording the prescription, or if if you have an Excel file, you'll manually import that Excel file into your your environment, and kind of like ingest that data. So for this first step, you'll have to, if you want to leverage say LLM to kind of like extract information from the the prescription, you can use maybe an example based prompting technique. But kind of like when you think about thoughts, yes, you'll have to decide. So now you have extracted entities. The second step would be to look up all the matching information in, say, like an external data source. So you'll have one type of prompting there, and then the third step. So all of this would become a chain. Got it? So
Yeah.
you will have a chain of thought prompting technique over here, where you'll be, chaining multiple steps depending on, depending on your use case. So here the use case would be to extract information from the prescription, consolidate it, and then find matching information in another data source, and then taking both of that together and generating an answer. So there'll be three steps over here. So you will have to specify the thoughts. Of course, those thoughts can change. The prompt language would be changing. So you'll have to do a lot of hit and trial methods, because the English, different words are associated differently. So you'll have to go back and forth over there. But yeah, you'll have to specify whether you will need chain of thought or not, like a thought based, reasoning based prompting or not, before you start. And that would require domain expertise, or some experience with prompting techniques, or some knowledge of prompting techniques. I hope at the end of this lecture, at the end of this webinar, all of you, when you go back home, you have some understanding of how to tackle prompt engineering, because there's a lot of things that go on. I might miss out on some important points that you need to remember, but you will know how to begin, how to start, and once you know how to start, it will all fall into place.
Yeah, I
I,
mean, that
yeah.
was the question. I mean, I wanted to understand like where to start, because the
Mhm.
example which I had mentioned, even if I have some another example where I want to have kind of decision related framework. So in that
Mhm.
case, what type of prompting will be paid? Will
I
be
think decision related framework where you have multiple steps, and where you have a particular pipeline where the LLM should behave at every step in a particular way. In those cases, reasoning based prompting techniques would help you much better, because example based prompting techniques, what if the LLM is not able to capture the entire thing of the example? Plus, our context windows come down when we provide more information in our prompt. So yeah, you have to ensure that the size of the prompt is also manageable. So that is the beauty of prompt engineering, that you have to kind of monitor the size of the prompt, because the entire prompt with the context is limited. LLMs right now have only a limited window. So the smaller information, the more information you can pack in like less words, the better your LLM would probably understand that prompt uh, at that step, and would have more room to kind of generate answers for you.
okay. Thanks for
No,
clarifying.
no worries. If you have any other questions, you can ask, and if someone else has something to add for this answer to this question, they can do so as well. Okay, so let's move on. So I hope everything is clear until today, until right now. Graph of thoughts. So we know what are nodes. It's similar to the graph data structure. The nodes are nothing but individual thoughts or concepts. So it will depend on the use case. So here the nodes would probably be those prescription drugs, and the relationship would be, if this drug is absent, this disease will increase. So the edges would kind of like decide the relationship. So suppose these can be two drugs, and what is the relationship between these two drugs? That can be the edge. And all of this concept would change from use case to use case. So I'm talking mainly about healthcare because my primary domain is healthcare. So if you have other like finance and retail and other things, so that will change. So graph prompting is like a road network. You can have multiple routes and paths to reach a destination. So basically, graph prompting is a more realistic way of modeling human thinking, where you kind of can ask the LLM to model different types of relationships in any number of directions. The LLM can trace back its steps, or change the route, or arrive at the same point through multiple routes, and all of those things. So that kind of human thinking can be modeled in graph prompting. So there are three major types. So graph of thoughts is what we are speaking of today primarily. So different thoughts have been aligned, and you kind of like give the LLM the capability to decide how to leverage functions from from those thoughts at every step. So as we go forward, we'll see how graph of thoughts is implemented in multiple frameworks. And knowledge graph prompting again is divided into two types, where one is either you're leveraging an existing knowledge graph, or second, you're creating a knowledge graph out of information that you have, and leveraging that. So somewhat similar, it's just an extra step in processing data. And hierarchical prompting is somewhat like similar to tree, but tree prompting, where you're like dividing the tasks into smaller, more manageable subtasks. But These are kind of like overlapping subtasks, so not like specifically very how do you say, very strict division like how you see in chain of thoughts or tree of thoughts. So there's another form of prompting that I wanted to mention over here, which is known as multimodal prompting. So that also can be incorporated in graph prompting. So where you like, leverage text, image, and code, and different types of data which is readily available, and kind of like arrange them in a graph like structure. So and then ask the LLM to generate a response depending on what your question is. Suppose image captioning, or diagnosis based on medical images plus text plus blood tests and etc and etc. So right now we were talking about the basics of graph of thought and graph prompting and everything, but now comes the grain of truth. You have to understand that graph of thoughts is actually a very recent technique. It's hardly been a year or so that people have started talking about it. So what I saw in the literature when I was preparing this PPT is that different people have come up with different concept of graph of thought. So ideally, you have to understand that graph of thought is not exactly like physically you drawing a graph and sending that graph. No, it's just a data structure which stores relationships, like how you leverage graph data structures to store information. That's all that is. So in this paper, in this is one of the earliest paper on graph of thought. In this paper, they are using the multimodal technique, or the multimodal prompting technique in graph prompting, to kind of like show you how graph of thought reasoning works. So as you can see the image over here, they're using text, they're using vision, and then they're using a graph of thought. So basically in this paper they use three different modalities: text, photo, image, and graph. So three different data structures to kind of come to the answer. So here the question has been asked, and this is the vision area, and this is the graph of thought features that have been passed, and the answer is received over here. Another interesting thing to note in this paper was that they say, so the engineers, the researchers have found out that when you move from a tree, like chain of thought to tree of thought prompting, you don't see a very huge improvement in accuracy. But when you move from the example based prompting to reasoning prompting, you see a drastic change in prompting, accuracy of the LLM. And I think that makes sense because when you're giving reasoning, you're kind of like providing the logic as to why this step has to be performed, or the steps have to be performed in a specific order. So it kind of like guides the LLM to behave in that way, and it's not abstract. So yes, it makes sense that reasoning based prompting techniques yield higher accuracy, but to be very honest, only on different use cases. So simple use cases like summarization, entity, and all of entity extraction and all that, it doesn't show exceedingly great performance. And it's all subjective. So again, like how I mentioned, it's depending on your use case. So you have to understand a little bit your domain and your use case to see whether you'll need reasoning or you won't. So this is the GOT framework, like graph of thought framework that has been mentioned in the previous paper that I showed. So here they have taken a thought graph that's nothing but uh, different thoughts being leveraged together. They have taken text here, that's a Q&A question, and they have taken an image. So they've given it as an option over here. But as you can see, they have separate encoders for these things. So they have a vision encoder for the images, a text encoder for the text, and graph attention network for graph of thoughts, and then the rest of the pathway, and then you get the final answer. So you get the final production answer. So these are there are optional areas as well, But
Seems a bit too complex, right? So
yes,
code implementation will be quite
quite
sophisticated.
complex. Yes, yes. So
There are so many things going on here.
yeah. So the problem with graph of thoughts is that it is not well received. To be very
Mm.
frank, chain of thoughts and tree of thoughts have kind of like, and now that we have RAG, and we have RAG with chain of thought and all of those things, they kind of take care of most of our use cases until now. Graph of thoughts, it is very interesting. It gives us a lot of room to experiment, but it is difficult to implement because it needs an entirely different. So when it comes to LLMs, it needs an entirely different attention network, and of course, it's a different data structure. So people should be very well thorough with graph data structures and understand graph theory. So those are kind of like the bottlenecks, and also. Since graph of thought is a lot like human thinking, where at every step you are leveraging multiple things, it becomes computationally extensive, very high heavy duty processing. So a lot of people have not moved into game like a graph of thoughts because of it being computationally heavy and time not time consuming, but yeah, storage extensive, yeah.
What is the gated fusion layer in this picture?
Gated fusion layer. So this is like this is the step where the large language model kind of looks into just a moment, I might be wrong. I haven't Yeah, so basically, this gated fusion layer over here kind of like integrates all of these modalities together. So the idea behind is that we have different we have graph data structure over here, we have text, and we have images as well. How do we combine them? So you can see that different encoders have been taken to kind of like get their vector representations, but they have been fused together to get the answer finally from the decoder. So we know that GPT models like ChatGPT and all those are decoder only models, but their only job is to predict the next token. But encoder kind of like takes into the captures the features of the data that you feed into those models. So this is the entire network. How do we combine different features? So this is what this layer does, combining all different features, different modalities, sorry. So in individual modalities would have individual features, right? So combining all different modalities. Okay, I know this is a little heavy duty, but we have almost come to the end of the paper, like end of the presentation. Just to take you through. So here I was talking about the multi-model form of graph prompting, like I mentioned here. This is another paper, and this paper gives its own framework of graph of thoughts. So I'll take you quickly through it. You can always read onto this because this is a little bit more complex. And if I, go in depth, you will forget everything that we have studied until now. So I'll just give you a brief overview. Here, the architecture goes like the LLM is here, and there are two areas. There's a prompter, which will kind of like, keep prompting the LLM, and there's a parser, which will keep extracting the LLM response. So this is like a cycle, this is like a loop. It will keep happening. There is an external area, there's an external, in terms of code, you can think of like an external variable or an agent known as the controller, which kind of like tracks what are the thoughts and also the reasoning state of the LLM. So graph of operations here is nothing but a blueprint of all the things that the LLM has to do. So like how in chain of thought you give first you extract entities, then you summarize, then you classify, right? So graph of operations would nothing be these three steps written in the order. So basically your logic written in the order, right? So the controller will take the logic as an input, kind of like holds the logic, and it will keep prompting the LLM. It will use the prompter to keep prompting the LLM and get the LLM's answers, and use the parser to get the LLM's answer. And it will keep a track of the graph of the operations ka order, and it will decide, it will maintain the ongoing reasoning. So I know it's a little confusing, but the graph reasoning state over here is nothing but the current state of the LLM. So let me give you an example. So this is how the graph of thought, this basically architecture looks like. All right. So you can see these are nothing but these operations, operation 1, operation 2, operation 3, operation 4. So these are nothing but your graph of operations. And this entire thing would be the controller, which will hold this entire operations. So the first operation is that the LLM has to generate 5 responses depending on whatever the question is. So here the question, maybe example is where the full documents are merged. So first 5 generations of the answer. Then a scoring would be done on those 5, and top 3 would be chosen. Like here, the top 3 would be chosen. Then from those 3, you will choose another best, and then again you will aggregate. So these are like a complicated flow of information. You can see multiple things are happening, multiple things are happening at every step. And after a few steps, there is a kind of like a keep best operation, which decides, out of all the possible methods, which one should we keep at this stage. And this goes on in an iterative manner. So here it decides 1, here it decides 2, here it decides 3, and finally it will, see, you can see keep best n. This would be the final one that it will keep. Graph of so these are graph of operations, nothing but your controller taking in instructions. So graph of reasoning state would nothing be the current state, which the controller will think, okay, step 1 has gone, LLM has given this answer, what should I do? So graph of reasoning state is the entire current scenario in which the controller is acting on the LLM and getting the response. I hope it is clear. Now you guys can tell me if you have doubts here.
Yeah, one doubt is at the bottom of this picture there is COTSC. So what is this SC? Chain of thought, then SC.
Oh, just a moment. I forgot the full form of SC.
Okay.
So I think if I
Self-consistency.
yeah. So I think they're showing the difference between what kind of chain of thoughts and how graph and tree of thoughts would work, right? So chain of thought is kind of like very straightforward, and it's a straight thing. You can't have multiple bifurcation. So you see from one step, it will go on to the next step only. It won't have a reasoning over here, whether, it won't directly reason over here that, whether it should do something else here or follow this or not.
This
And I
graph
think this,
reminds me of the data structures, right? So it is a data structure, I guess.
yeah,
So
they're
we used to
leveraging a data.
implement programming data structures we used to have, which Microsoft, the FANG company, job interviews will always ask. But now
Mhm.
you're doing the same graph concept with the the LLM
Yeah,
output. So you are implementing a data structure of thoughts.
exactly. So in my experience, I think this I haven't been able, like, unfortunately I wasn't able to run this GitHub repo. So if you go to the paper, you'll find the code as well for this. And this code is actually based on an older version of OpenAI, an older version of LangChain library actually. So a lot of dependency issues were there, so I couldn't iron them out. But this is a much more interesting way of tackling, graph prompting. So here you have the what do you say, the control over deciding what operations to add at every step. When you're using a thought graph, then so you have to understand, when you're looking at leveraging information, then maybe a thought graph is much more important. But when you want to leverage reasoning, when you want the LLM to understand and kind of like, reason itself into coming into a correct answer, then this framework would be much better, uh, much more easier. But yes, as you can see, in order for us to do a very small level of graph, it has to take like almost 10 steps. So yeah, it is computationally extensive, and also absolute information and expertise is needed to kind of like integrate graph of operations and this framework here.
So Dolcy, one question is how the embedding from a graph that we can generate, mainly the graph embedding, how it comes.
Actually, it's a very good question.
No, I
um
mean, yeah, I can answer that if you want. So we have a course in graph neural network, Partha. So we have 2 years back we launched a course in graph neural network where we discuss all kinds of graph neural networks, and there are very good ways or robust ways of embedding a graph and then mining the graph from that embedding. So that
In a
part is
brief
already
answer, if
solved.
you can,
Hmm?
any brief way, like this is the way we do that, that embedding.
No, it was there were some Python libraries for graph embedding, right? So it was just part of the graph libraries. There are various companies which have provided graph Python APIs, such as Neo4j and many others, and DB Graph, and they will provide some embedding, APIs, which we'll do. We didn't do deep dive into the embedding architecture of graphs, but there are robust Python libraries to achieve that, and we have used that extensively in our graph course. We have presented a lot of graph neural network webinars over the last few years. So that embedding of graph was already solved. Now, how a graph of thought will be embedded, I should not, I guess, relate it to that. A graph data structure was easily embedded, and I'm assuming the graph of thought embedding would be the similar process, because after all, it's just a data set and it would be
so
stored in a quantized way.
Sir, just to clarify it here, so graph of thoughts, guys, is basically nothing but an order in which you will get the LLM to perform operations. When we talk about graph data structures, that is actually holding information in the nodes and relationships. So, leveraging a thought graph. So I know it is a little confusing, and it was confusing for me also, but bear with me. So there are two ways of tackling graph prompting. We can say one is when you have a graph data structure of information. So let me quickly show you. This is a graph data structure of medical information of a particular medicine, of a particular disease. So the disease is mentioned somewhat here. It's basically it's a class, it's a organization. Let's not think about that. So okay, so this is information, this is in knowledge basically, right? And these are relationships. So when you're leveraging this kind of a graph, it is known as a thought graph or like a graph data structure, and this can be embedded like how graph data structures are embedded normally. But the graph of thought prompting is kind of like this, where you're like specifying different operations at different steps, and it can be that you're leveraging an existing knowledge graph and doing prompting based on that. I hope it is much clearer now. So this won't be embedded, these operations won't be embedded, but that data structure, if you're leveraging that knowledge graph per se, then that would get embedded the same way it was embedded earlier.
So Dolcy, one related question which Vivek just touched in an answer. The question is that is not actually how graph embedding works, but the question is one step forward in chain of thought or in graph of thought, will the embedding of each node being passed from one node to another, like how the water flows from one point to the another, then one point to the another. So when a thoughts being propagated from the root node, then the next level of non-leaf node, then non-leaf node. So in this way, if those thoughts are connected, will that mean a embedding of each of these nodes, or the related embeddings will be propagated like a water flow? Like, is this the way the thoughts are getting connected, or that was actually my question?
So again, graph of thoughts here are nothing but operations. Okay. So graph of thoughts won't be embedded. But if you're using a knowledge graph, so there the nodes and their relationships. So how it will get embedded? Each node will get embedded with all its relationships, right? So all its information about what are the connections leaving that node and what are the connections coming to that node. If there is any self connection, self attention connection or something like that. The knowledge graph would be embedded, and it would be embedded in the same way. But here we are not embedding anything. We are just guiding the LLM to perform actions in a graph like format. I hope I've answered your question.
Yeah. So even though we are just prompting, those prompts are not getting embedded.
Embedded, not here, not in this case. So not in this format. So yeah, there are multiple ways of tackling graph of thoughts. So that is the problem. Chain of thoughts, tree of thoughts, and example based prompting techniques, they are all very straightforward. It is common for everyone. But graph of thoughts, because it hasn't been explored much, and it is a little bit more complicated than all the other prompting techniques, people have come up with their own architectures. So that is the reason why I go through three different architectures here. So this is like the second architecture, and this would be the third one, the one that you asked, where and the one that Vivek sir also mentioned, that a knowledge graph is existing. That graph is kind of like embedded. So this can simply mean a rag sort of a thing, but on knowledge graphs.
Yeah,
I
this
think
is a data. This is actual data, so it
Data.
will be embedded, and signals can flow between the nodes. Yes,
Yes.
signals flow between the nodes, so one node impacts the other nodes. Yes.
Exactly. Yeah.
I think if instead of you look at this as a graph, if you look at the nodes and the relationship as a tabular format,
Yeah.
this data is derived from a tabular format. All the nodes and relationships are represented in a tabular format. Once you have the data in a tabular format, embedding is a straightforward translation of your content to a embedding format. And the chain of thought as well as the graph of thought is basically querying this particular tabular content. That's it. That's the understanding.
I think, Prasanna, let's say now in the image, each of these nodes looks like a table, but maybe if it is not a table, one example maybe a UML diagram, or maybe some scattered image, which may not be a table, that means the query is also not possible in that case.
No,
Then
no.
maybe,
See, any graph, how do you all the node and the relationship, you can translate that to a tabular structure. When you look at how the embeddings are done in Neo4j or any other tools, and the approach is this: the graphical representation is translated into a tabular format, and the embedding is applied on the tabular format, because any representation that you are doing in a graphical form, you can translate into a tabular structure. At the base is basically a tabular structure where you define what are all the nodes and what is the relationship between the nodes. That's it.
okay, thanks.
So I hope that's clear. So let's move on to knowledge graph. So like how I discussed, knowledge graph prompting can usually mean that you have an existing knowledge graph that you can leverage. So depending on your choice. So suppose I want to have an answer, what are the symptoms of a particular disease. So depending on my question, the LLM will move on to that particular node. So it will sample all the nodes and it will move to that node where it can find the possible answer, and from there it will take a subgraph. So suppose for my question, it has to come down to this node. So it will come to disease, and then it will model all of its relationships around it, and then decide whether it is enough to answer the question, or does it have to go to the next node and leverage that as well? So somewhat like a little complicated form of RAG in this case, in this specific case. But then there is another form of knowledge graph prompting where the information has been given, the text has been given, and the large language model is kind of guided to design a knowledge graph from it and then query the graph. So it's somewhat similar, only overlapping pipelines. But yeah, you can do it either way. You can create your own knowledge graph and do it, or you can leverage an existing one as well. So why, why knowledge graph prompting is different from the traditional vector similarity search that we see in RAG is, first of all, we are leveraging a graph data structure. So graph data structures can help us model relationships between different, say this is a use case for passage retrieval over here. So it's an example for how knowledge graph prompting would be much better for performing, much better at answering or extracting relevant information than our traditional vector similarity search. Because you, as everyone, I hope everyone knows that vector similarity search is nothing but comparing the vector representation of the text. So vector representation kind of, you lose a lot of in-depth information in vector representation. It's because you are representing an entire sentence or an entire word through a means of a number. So of course you will lose you will lose features of that information of that text. So knowledge graph prompting kind of overcomes that problem, because graph structures are capable of modeling relationships, subjective relationships as well, and don't always need numerical representation, is the reason why it will do much better. Then again, guided traversal. So again, like I mentioned, it can use the language model and reasoning kind of like guide the we can specify the reasoning logic, and the LLM can decide which roads to traverse or not, whether the road traversed are correct, or whether the information needed for the question is there in the graph or not, etc., etc. Then multiple steps. You can like how I showed you the outline of the graph of thoughts, the entire diagram of the prompt, where you can see that through different channels you can come on to the same so let me quickly show you. Through different channels you can come on to the same answer. So suppose now, let's say, you can see that if you see on the right hand side, suppose the LLM is here and LLM moves from here to here. Now you can see there are 1, 2, 3 steps involved. But in order to come here, it could have taken 1, 2 steps also, right? So these multiple step thing can actually help us find or come to our answers quicker. Suppose we came through this step and we reached over here and we realized ki, oh, this node is actually connected to the main node through this pathway also. So we will guide the LLM, or we will make changes to our logic so that the LLM takes the shortest path and gives us the answer faster. So that kind of capabilities we can leverage in, graph prompting, but not in chain of thoughts or any other type of prompting. Then context modeling, again, like how I told you that, you can decide, the LLM can decide whether the information is there within the context or not, whether, accurate information has been done. Then it can kind of like, do a ranking on the information that is retrieved. And again, it can decide whether it took a long path or a short path and all of those things. And of course, again, because we are capturing relationships more humanly, we can capture topical, semantic, structural, even temporal entity. So I want to demonstrate that. So I actually, I will demonstrate that at the end. So over here we can see an example of knowledge graph prompting. So you see that there is an existing knowledge graph for consumer electronics, and user asks a question. So the question is, write a product description for a new smartphone by emphasizing, the relationship. So here you are writing a prompt in sort of a graph, not a graph structure kind of a way, but you're like giving information in between. So this is what we usually do. We specify input data, like how we saw in the anatomy. So this is input data where the entity is Samsung Galaxy S23, and there are two relationships mentioned for that phone: better camera and longer battery. And what we want the user to we want the LLM to write a new product description for a new phone which is similar to Samsung Galaxy. So this becomes faster because knowledge graph already has information for Samsung Galaxy, which can be queried, and LLM can give us a relevant answer over here. So again, this is a form of RAG, but RAG on knowledge graph, because knowledge graph is a much more uh, humanly way of capturing relationships in real world. Any questions until now?
So here, are you saying if we use that shortest path technique, it will be faster retrieval?
So yeah, knowledge graph. So you have to understand that the knowledge graph is not dynamic in nature. You've created the knowledge graph once, and you'll probably be leveraging that. So if you're like adding on to that knowledge graph again and again, and it's a huge thing, then it will slow down, of course. But yes, this is much faster because instead of just doing a simple vector similarity search, it can actually go to that relevant node and leverage information from that relevant node.
Okay.
Plus see, there is a domain specific reasoning thing coming over here. So you someone who an AI developer who is not from a particular domain actually can augment their answers or augment their applications by leveraging existing databases like knowledge graphs for their specific use case and stuff, to kind of like drive product development or pipeline or workflow, whatever you can say.
Like here, like I had one use case, like where we were using this vector similarity to for
Hmm.
retrieval. Now, let's say instead of that, if I use this knowledge graph and then if I follow the shortest path technique, in that case, will the retrieval will be faster or not?
So it's again a very subjective thing. Like I don't know if I should completely say that, because if depending on what kind of way you're querying from knowledge graph. So right here they have shown that they are actually finding the relevant node through a similarity search also. But through that relevant node, it can the LLM can do a reasoning whether that node is enough or not. I think if someone else can step in and say if this is the whether it will be faster through this, I'm not exactly sure about this. So I think Vivek sir or Indrajit, if
Yeah,
you
it
guys.
needs a lot of hit and trial,
Yeah.
right? So graph, this graph-based prompting is not easy to implement, as we have seen. So it will take a lot of hit and trial. Just implementation itself is very complex. So performance compared to existing, RAG pipeline is hard to say. We it is better to we keep the solution simple. If RAG is doing justice or reasonable justice, we stick to it, because bringing in graph, implementing itself will be very difficult.
Yeah.
Okay.
And I think it will take a little longer, maybe not the querying part, but the reasoning part would take a longer time, because as you saw in that template, there were multiple steps being carried out at one particular, multiple tasks being carried out at one particular step. So yeah, it becomes very complicated because graph can expand in any direction, right?
Hmm.
So you will have endless connections in every way, which way. So even if you have the shortest path, what if there are 10 nodes in between? There's no way you can do anything about that, right? If the two informations are separated by a long path, it will take time.
Okay.
Dolcy, I have a question.
Sure.
So in this diagram, if we see, so the user is writing a question, and then we are retrieving information, some context from the
Yeah.
knowledge graph, which could be in say Neo4j, and then that context plus query we are sending to LLM and then generating answer. This flow is fine, but this question, how are we retrieving information from knowledge graph? Are we converting that natural language into a cipher query first by sending it to LLM and then retrieving the information?
Yeah, you can decide that. Like, that's again your choice. I think the cipher query is something that actually goes in knowledge graph. So depending on whether you are creating a knowledge graph first or you are just leveraging an external graph, that
Suppose we are leveraging a knowledge graph. I mean, how easy it is, because that itself would be a project, right? I mean, converting NLQ or natural language question into effective cipher query.
yes. That's also a very, so that's the reason why all of this mostly is seen in theory. So you don't see, I did not find a lot of implementations of, graph prompting techniques online. And coming to your question, so yeah, cipher query or vector similarity search is carried out, but I think it's it's also about, if I'm not wrong,
So
anybody else can
this
also.
could be a project in itself, I'm saying, because
Yeah, yes,
Basically,
yes.
we have a client project going on right now.
Mhm.
We started with two different solution implementations. It was a bunch of Excel files with some rules for a chemical industry use case. So we started two parallel approaches because we weren't sure which approach will work fine. So we started creating, representing that Excel file dataset into a D graph. So D graph is just like Neo4j. It's a very popular graph architecture. So we ingested that Excel file dataset into a D graph, and then we were trying to mine it with graph neural network for relevant recommendation around the cosmetic formulation. But that proved to be Herculean task. It was very difficult to convert it into a proper graph and then mine it. The second parallel approach we had started with a different team was we created a RAG, a CSV miner RAG on it, and using, let's say, VV8 vector database, and then we were just querying the LLM with that context. But then even we didn't need RAG, we just implemented a data frame, put the CSV file into a Python data frame, and then ran a SQL programmatically. We ran the SQL and sent the SQL query as context to LLM, and it is doing wonderful job. So our attempt to solve this problem with dgraph architecture failed, but when we tried with a LLM pipeline with a contextual query, it worked beautifully, and that's the solution which has now gone into production. So just I'm comparing that how we tried with a straight LLM with context and dgraph based, data mining recommenders, graph based recommender system. Graph based failed because it was very difficult to implement. It was giving too many issues and we could not overcome those issues. So we gave up on that solution. So unfortunately, graphs are very fancy, very interesting. Real implementation still needs some time. I think these big tech companies have to, produce more easier graph libraries to work on. Till that time, I think graph will remain more of a research subject, I feel.
Subject, yes. So mostly graph is also, even when you see it in daily use cases also, if you see, graphs are usually utilized in modeling very heavy duty relationships like weather forecasting, or real time traffic monitoring, or how much time will it take, or all of those things. So those use cases have more than 20 features. So there are 20 columns, deciding more than 20 columns deciding what would be, whether it will rain today or not. So in that case, how do you capture the relationship between the first feature and the 20th feature? So their graph modeling becomes more accurate, more interesting, and also legitimately, like, it makes sense to use there, right? Because it makes it easier for us there. But if a place where you don't need graph prompting, where the use case is not complicated enough and it is not leveraging a lot of features, a lot of dependencies on other external factors, then I think you should not no need to dive deep into graph prompting, because
Right, right.
you'll be wasting your time and you'll be wasting your compute time and your storage and utilities, and you will learn a lot no matter what.
But no, but it's a valid use case actually. In fact, we are talking
Yeah,
about
you
customers.
won't be able to apply it to every use case. That's the problem. So if you learn chain of thought today, you will be able to apply to chain of thought everywhere, right? But no, it's not the same with graph prompting. You learn it today, but so that is the reason why not a lot of people have,
No, no,
uh,
no. But I'm saying there are use cases, especially like in the pharma domain and
yeah, drug discovery and all those things.
yeah, yeah. So right, so there are a lot of graph structures are there. Like one disease,
Hmm.
for one disease, which are the medicines specified for one medicine, which are the diseases.
Yeah. Recommender systems, whether you have this disease, then what medicines, all
Right.
of those
There
things.
are clients who are asking, analytical based interface on their knowledge graphs. So that's
Yeah.
what I was asking question whether we have seen some solutions already, or we can always give a solution at a high level, but implementing whether it really works.
So implementing knowledge graph prompting, I think, is a little bit more simpler than implementing graph of thoughts, because here essentially you are querying a graph data structure, and whereas in graph of thoughts you have to model your operations in a graph-like format. So that takes a lot of domain expertise. So what I found when I was researching through for preparing for this webinar is that you need domain expertise to be able to leverage. So knowledge graph prompting is a lot similar like RAG, but for any other use case or for any other type of graph prompting architecture, in those cases your domain expertise is absolutely important, because you have to hard code the operations at the level of designing, at the level of writing your script, or at the level of writing your use case coding your use case. You have to hard code everything. Every step the LLM takes has to be needed. So this is also one important thing, that if you are a domain expert, only then you will be able to kind of like write all the rules, all the possible rules that are needed for the LLM, by the LLM, to answer that question.
Yeah. That's true. Yeah, domain expertise is definitely needed.
So graph prompting, it is very important. It is imperative. Chain of thought, you don't need that much. As long as you understand the data and the flow and a little bit here and there, it is easier. But yeah, graph of thoughts, you need to leverage domain expertise. Okay.
But
So
here, if you go back to the previous slide, I mean, is there any kind of scope to improve the searching speed with that factor similarity search speed?
yes, so similarity search is one way of conducting retrieval. There are other methods. So there's I think multi-hop and dense. I'm not sure. Not multi-hop. So there are other types of searches, retrieval techniques.
Which
Uh,
will be faster, you are saying?
yeah. I think some. I am not. It's not. I am not remembering the name. But yeah, there are other many ways you can. So you will have to kind of like map reduce. So there's map reduce, and like how similarity search is there. There's semantic search. Then there is map reduce. So there are different ways of querying information. Basically, how do you match your query, your user's prompt to the existing knowledge that you have, right?
Yeah. Yeah.
Because your existing knowledge would be in chunks, different
Mhm.
chunks, and those chunks would probably have a vector representation or not. You don't know. So how do you match your query to that? So similarity search is one way of matching. So if your query vector representation is closer to any of the chunks in the knowledge graph, then those chunks will be pulled up as relevant information. But again, the other types of techniques would kind of like look at other properties of these chunks to match your, to match relevant information.
Okay.
So if it will increase, so the speed varies depending on which technique you're using.
Okay.
So similarity such is the most basic one that we use, but there are higher, better ones depending on. So you have to. So there is a trade-off everywhere in a generative AI. In an AI project life cycle, there is a trade-off everywhere. Sometimes you're trading off time for storage. Sometimes you're trading off the other way around. So sometimes you're trading off, accuracy, precision. So here you will be trading off precision. This won't be very precise, but yeah, this will still give you a much more realistic answer than, doing it manually, let's say, or like doing it another way, or something like that, without embedding or without performing a similarity search.
Right.
Okay. So, actually, this is just a survey of different types of prompting techniques. It came out last year. So, nothing but how you design. So, discrete is that you have manual templates for every step, whereas continuous is that, you represent textual information of a graph as embeddings. So, instead of writing prompts directly, you convert the information into a graph and you embed it, and then you keep attaching that textual information or that graph basically. So if you guys remember the first paper that I showed you, where they were leveraging a thought graph and converting it into a vector embeddings, so it's somewhat like this, where you keep adding those vector embeddings to your inputs, and you keep creating prompts. So this is a way of creating prompts basically. Okay. So yeah, I wanted to show you guys. This is this is the last slide. So sorry for overloading you with a lot of information. So this is this is a knowledge graph that I had created to kind of like show you guys how we can capture multiple modalities. So this is nothing but the blood coagulation phase. So when you have an injury, so you start with it, you have a vessel injury, right? And then this receptor is exposed, then this factor is released. So I want you to see, you can see the way the information is being modeled, right? This part over here is part of the phase one. So this is phase one. The left side is phase one. This is phase two. And the third phase I've not shown here. So phase one has a direct role on phase two, like in this way, but it has an indirect role through other places also. So this structure gets stored into granules, which again are attached to the second to the platelets, and then they cause another thing. So I don't want to go into the physiology of all of this, but you see it is able to model the temporal nature, right? Also model different textual relationships. So these are like subjective relationships. I have not mentioned numbers or say a particular vector or a particular numerical representation. No, these are texts. So you see irreversible changes in shape and size. So you, from this step, if you see, if it goes here, it can't go back, but before this step it can go back, things like that. So all of these information, this entire process is captured beautifully within this structure. So that is what I wanted to highlight over here, that this is how you can leverage real life entities and kind of capture relationships and temporal and spatial relationships as well in your data. So finally, coming
Dolcy,
down.
one question is that in
Yeah.
your previous knowledge graph, if there could be some entities having ambiguity, means that similar terminologies or meaning wise ambiguity, then how we can disambiguate those entities while we are creating this knowledge graph? Any idea?
uh, So I am guessing. If I am, I'm not sure if I'll be the right or not right to say this, but you see these connections, you see these edges, right? So these edges and these nodes, they kind of like capture semantic understanding of the text, right? So they are not capturing anything numerical, or we're not converting it to anything numerical. So even though there might be some ambiguities, I think when you are leveraging these when you're creating these graph structures, so here I was creating it manually. But if you ask the LLM and you kind of like go back and forth with a little bit of prompt techniques, or different kinds of prompt techniques to kind of like aid in knowledge graph creation, there maybe you can you can specify within those, with before creating knowledge graph, within the operations, you can specify the ambiguity, or you can capture those differences. I'm sure there'll be other ways of tackling this. So if anyone has any idea about other ways, they can also mention it here. Okay. Did I answer your question, or do you have any further
Yeah,
clarification?
yeah, to some extent, got it.
Okay. So yeah, I'm sure I'm also a little new with the graph prompting techniques, and of course there's a lot of it that can go that goes into this. But yeah, definitely we can dive deep after this call and see. So, coming to almost the end of today's webinar, so why do you think graphs are important? So, if, you can use it cross modality, like the first template that we saw, that we can use images, text, and graph structures in itself, or you can, maybe say documents, and then combine them together to get an answer, which is much more realistic, because human beings take decisions based on multi-sensory modalities. So we hear, we think, we sense, like we smell and we see, and all of those things we use to take a collective decision, right? And we also retrieve contextual information from our memories to kind of like drive our current decisions. So cross modality is kind of like captures beautifully the human way of thinking. Cross domains, because you can go check it out in healthcare, you can find use cases in retail, you can find use cases in, say, geography, weather forecasting, social sciences, everything whatsoever. Then it gives you multiple levels of abstraction. So at a graph level, you can decide whether an entire molecule inhibits a particular disease or not. At an edge level, whether these two nodes are connected. So this node can be maybe Steve Jobs' name and his information, and this node can be, let's say, Apple. So there can be a connection between this node to this node, saying that Steve Jobs founded Apple, right? And then the node level area, so this is like, at this node, suppose this is a node of a guy who has been stalking you for a very long time. So in your network, you flag this node, so whoever comes to this node can know that this person or this account is a malicious account, and so nobody would traverse that account, or make a preemptive check that whether the next account, whether the next node is malicious or not, whether I should travel there or not, something like that. And other prompting techniques that you can explore, creativity oriented, when you want to write poems, codes, and style, you specify a style. And then meta prompting is basically guiding model adaptation for better generalization. So these are like advanced techniques, and these are all like, so React is kind of like reasoning and action. It's reason and act within an environment where you specify the context of the environment. But meta prompting is used in training the LLM models as well. So kind of like guiding the LLM to generalize on the data. So that's all from me. So yeah, that's a joke to end on. I hope you guys had fun, and you can reach me out on LinkedIn if you have any questions or doubts.
Okay, excellent presentation, Dolcy. Audience, any final questions?
Let me check the text if there are anything on the chat. No, there is not. Yeah. So guys, if you have any questions, you can ask.
You are going to show CellBot, I think, but I know we are a bit over time, but you can quickly show
Yeah,
CellBot.
I can show.
But most folks here are existing members, might have seen it already. So we have a healthcare product Dolcy is developing for CellStrat. Go ahead.
Yeah, okay. So as you can see, so what Cellbot is doing right now is that you are basically deciding a topic of discussion. So let's say here my topic of discussion is diabetes and its symptoms, right? So now my bot on the back end, it will go to PubMed, and depending on this query, so we have formatted this query in the backend, and depending on this query, the bot will pull the top 100 research papers from PubMed. For now, we have kept it to that limit because of the latency issues and all of that. So, top 100 research papers from PubMed, the latest research papers from PubMed on diabetes, and then it is converted into a vector embedding and it is stored in our V8 vector database, our instance of that. And now we can query it. So, this is like a PubMed RAG miner, but yes, we are adding archive to it as well. So let's first have an idea. What is diabetes? So let's see what does it respond. So right now we're using Chat GPT. So as you can see, it generates an answer pretty well on different
So you are
types
not
of.
using Chat GPT that you inadvertently said you are using Chat GPT.
Oh no, sorry.
We are using GPT-4 API.
Oh, GPT-4 API, yes.
Yeah.
Sorry. So yeah, as you can see, it generates an answer and kind of like, so right now we are working on a few more things. So by the next week, you will see that, whatever the LLM has used, relevant information from our vector database, it will be printed at the end. So you will get citations of individual answers for every answer, and then you can deep dive into those citations. So if those citations have open source papers in it, you will be able to look at those open source papers, summarize them, download them, or even do RAG on those open source papers. So right now we are pulling information from PubMed, but we have also devised another pipeline where you can choose to pull information from archive, and you can of course go ahead and have further discuss the treatment in diabetes. So the whole point of this tool was to bring latest medical research to everyone. So you have to understand that medical professionals and even patients and caregivers, they don't have a lot of time, and they want to understand their topic of choice quickly, and they want to make sure that whatever information they have is correct. So this is like a kind of like a guardrail sort of a thing where we have specified the LLM to only take information from PubMed and PubMed alone and answer on basis of that only.
The PubMed, we are calling the APIs. How are you
Yeah.
getting the data?
Yeah. So PubMed and Archive, both of their APIs are URL based APIs, which kind of like return an XML or an HTML response.
Mhm.
So you can scrape those websites. Yeah.
Okay.
So we are doing all of this in real time, by the way. So in real time, you go to
How are you?
PubMed and Archive.
How are you? So you are firing a lot of requests to PubMed, like when you question we are typing here.
No,
How
no,
are
no.
you?
So we have designed the workflow in such a way that it doesn't increase the rate limit of PubMed. And we are only making an API call to PubMed from the first page. So right now we are making a public API call here when we are choosing the topic of discussion, right? So based on the topic of discussion, our bot will extract information from PubMed. So once it has extracted and consolidated and embedded that information into our V8 vector instance, vector DB instance, we can query it
Correct.
any number of times, right?
Yeah.
Yeah.
Got it.
Yeah. So we'll be adding. So yesterday only we deployed the archive pipeline and the citation pipeline and the deep dive pipeline. So maybe within a week or two you will see many new features and an entirely new outlook of Cellbot. And honestly, that will be a much better version, because we wanted to add a lot of features, good features that would actually be helpful to people. So yeah, those are coming in. So watch out for our newsletters and our LinkedIn space and our meetup space. We'll definitely be showcasing that Cellbot there again. So you guys can leverage this for in-depth understanding of any medical topic whatsoever. And eventually you will be able to add your own data to Cellbot. So we will set up pipelines where, if you have an existing research paper that you don't want to, like you already have that paper and you're not getting it online and you want to understand that alone per se, so you can do that as well. For now, if you want to do your if you want to talk to your own databases or your own PDF files, you can use our another product called knowledge base miner, where you can use PDF, PPT, CSV doc and text, and even URLs for that matter, and perform RAG on those, and understand your own documents better.
So friends, we are looking for strong GenAI developers to work as interns in these product teams, working with Dolcy and Indrajit on knowledge base miner. So we are very keenly looking for contributing, community interns. So if you have the hands-on expertise in generative AI, solutions or cloud deployments of GenAI, then please reach out to me. We would be very keen to engage you as a product intern.
Great. So
we also have a live course on Generative AI Foundation, which is being run Sunday morning, India Standard Time, every Sunday. So our 4th class is tomorrow. And those who have not yet enrolled, I invite you to enroll. It does have a prerequisite of MLDL knowledge. So we have a comprehensive course which includes MLDL and GenAI. If you know MLDL, then you can directly enroll in our GenAI course, which is happening every Sunday morning. A live cohort is going on. So any final comments? And I know this is a superb session by Dolcy, but any final comments? Okay, so that brings us to the end of this webinar. Dolcy, exceptional presentation. Thank you so much. And your vast research and knowledge always clearly comes out. Thank you, audience, for engaging with your deep questions.
thank you. I hope if you guys have any doubts or anything, you can reach me out on LinkedIn, and we can have further discussions. Thanks all. Okay.